This video is illustrating the idea of using elementary accumulation functions to create more complex accumulation functions. So if I start with a simple accumulation formula, here 1/2 x squared is the accumulation of z dz with respect to x as I start from 0 and integrate to x. So what I'm going to do is I'm going to multiply both sides of this equation by 2. They cancel on the left, and that constant multiple moves inside the integral on the right. What this shows is I have a new function that's an accumulation function. X squared has a rate of 2x. Let's do another one. If I start with the simple accumulation formula that x is the integral from 0 to x of 1 dz, then I can multiply both sides again by a constant. This time I'll multiply by 5. Simplifies on the left, and the constant moves inside the integral on the right. And now I've discovered that the function 5x is an accumulation, and it has rate 5. What I can do now is I can combine these. So for example, I could take the x squared on the left with the 5x on the left and combine the integrals on the right, and by the sum property of the definite integrals, I can combine that to make a single definite integral. What that tells me is now x squared plus 5x, which is the sum of our earlier functions, has a rate of accumulation of 2x plus 5, which is the sum of the rates. Now I could add a constant to both sides, and that constant only affects the initial value of the accumulation. It doesn't affect the rate at all. So here x squared plus 5x minus 3 has the same rate of accumulation, 2x plus 5.